Welcome to Physics World Online College, where we explain physics and make it very simple, clear, and understanding to everyone. In our class of today, we shall look at a new topic, projectile. It is a follow-up on the last topic I discussed, motion under gravity. There is a link between the two, which I will establish in the course of discussing this topic. As our objective for today, we'll define projectile, give examples, know what is a trajectory, define projectile motion, and also give examples. And then I will highlight some points about the motion of a body following a parabolic path. Let's continue. What is a projectile? This is an object. If I throw this object up, it will go up, gets to a maximum height, and then starts coming down. That path trace, you see, is a curved path. We call it parabolic path. Now, as I throw the object up, the object is influenced by what? Gravity, the force of gravity, and air resistance or air friction. So this object, when thrown with initial velocity that follows a path determined by the gravitational force on it and its weight, or air resistance, we call it what? A projectile. So we say a projectile is an object thrown into the air or launched into space and moves freely under the influence of gravity and air resistance or air friction. We can also define a projectile as a projectile is an object that is given an initial velocity, and subsequently follows a path determined by the gravitational force on it, acting on it. This gravitational force acting on the object is also the weight of the object, that is its weight, and a resistance. I said you can also call air resistance air friction. That's a projectile. Examples of projectile. Examples of projectile are a thrown rubber ball, rebouncing from a wall. Number two, an athlete an athlete doing a high jump. We can also call it a high jumper. Number 3, we have a bullet or shell fired from a gun. Number 4, we have a battered tennis ball. A battered tennis ball. That is a tennis ball that is hit against a vertical wall, or a tennis ball hit against a vertical wall. A vertical wall. Then, number 5, we have a stone released from a catapult, or you say a stone shot out from a catapult. So we also have an arrow shot out from a bow. So say a projectile. We have an aeroplane or any aircraft that has whose fuel has been exhausted. Any object, any flying object that loses control with the control tower or base station becomes what? A free falling object under the influence of gravity, and it's a projectile. So you can get other examples from your text. Now, what is a trajectory? We say, what is a trajectory? A trajectory is the path followed by a projectile, the path traveled by a projectile. And this trajectory is usually parabolic in shape. This curved path is usually what? Parabolic in shape. It's a parabola. So let's take it as a trajectory is the path traveled by a projectile. You can say it is a path followed by a projectile. You are right. Or the path, the curved path followed by a projectile. And like I said, this trajectory is usually parabolic in shape. It is usually parabolic in shape. Let me sketch that part. If this is the plane of projection, your horizontal level or ground, you throw the object up, it goes up, becomes obtain maximum height and start coming down. This path followed by the object is the trajectory, and this shape is a parabola. So this shape is what? A parabola called trajectory. So all the examples we have here, you will always see that the object takes this path influenced by gravity. So when you bat a tennis ball, there's that curved path under the influence of gravity. You fire a bullet, that's that curved path under the influence of what? Of gravity. So this curved path is called the what? The trajectory of the projectile. Next, we need to know what is projectile motion. Now, in external exams, especially WAEC, they want students to know the difference between projectile and projectile motions, and then difference between examples of projectile and examples of projectile motions. Because if you are asked one and you state the other, you will not be given the mark. So you have to be very what? Careful. So what is a projectile motion? Projectile motion. A projectile motion is the motion of an object along a curved or parabolic path under the action or influence of gravity and air friction. I told you air friction is another way of saying air resistance. So the motion of the projectile is called projectile motion. Good. So when they say examples of projectile motion, then they expect you to say it in this format. Examples of projectile motion include, you will see the difference. I will be listing these examples, only that I will now add the motion of. So we say number one, I will say the motion of a thrown rubber ball rebounding from a wall. You will see that now. So if they say examples of projectile, you will say a thrown rubber ball rebounding from a wall. But if the question say examples of projectile motion, you now say the motion of a thrown rubber ball rebounding from a wall. Number two, the motion of a high jumper, or you can say the motion of an athlete doing a high jump, or the motion of an athlete doing a high jump. You see the difference is in the way you put the statement. So another example will be the motion of a bullet fired from a gun. The motion of a bullet fired from a gun. Do you get that? Number four, I will say the motion of a battered tennis ball. So I believe you can list other examples of what? Projectile motion. You can list other examples. You can say the motion of a stone released from a catapult. It's just to put those word, the motion of. The motion of a stone. The motion of a stone shot out from a catapult. I will leave the other two for you to fill up. Having known what is a projectile and a projectile motion, and the examples of what? Projectile and projectile motion. Now, there is a point I want to establish here which will be useful to us in the next class, which is this. Take note, any projectile or any object that is thrown and is influenced by gravity and air resistance has two motions. Not just two motions, but two independent motion. Not just two independent motion, but two simultaneous motion. So let me put it this way. The thrown object has two motions occurring simultaneously, but they are independent of each other. So a projectile carries out two independent motion, namely we have a horizontal motion and a vertical motion. Take note of that. Two simultaneous but independent motion. Now, things you need to know about that horizontal motion. Like I said, there is a connect between projectile and motion under gravity, because I have used this assumption in my derivations in motion under gravity. So I'm now explaining it here, and I will apply it even further in the next class. So any projectile carries out two independent motions simultaneously at the same time. One, a constant horizontal motion. Two, a vertical downward acceleration of free fall due to gravity. Let's list out some points you need to know about the horizontal motion. Number one, it means that for the horizontal motion, the body or projectile moves with constant speed or velocity. And from our knowledge of motion, uniformly accelerated motion, once the velocity is constant, the acceleration is zero. So which means for a body that is moving with a constant velocity or speed, its acceleration is what? Is zero. So we use the statement at constant speed, at constant velocity, A or G is what? Is zero. It also means that for the horizontal motion of the projectile, the range or the distance is independent of gravity. That is, acceleration due to gravity or gravitational force does not affect the horizontal component of the motion. It also means that the horizontal velocity remains unchanged until the body hits the ground. All of these points are repeating the same thing. It also means that the initial horizontal component of the velocity is not affected by vertical acceleration. So we assume that A or G is equals to what? Zero for the horizontal motion. Take note of this point, because like I said, I will apply it in the next chapter, or the next subtopic I will discuss, which is actually for horizontal projection purely. Then lastly, it means that no force acts on the body in the horizontal direction or S direction. This is what we mean by horizontal motion of that body that is under the influence of gravity. let's take the following point. For the vertical motion, this vertical motion of this same body or projectile under the influence of gravity, for the vertical motion, this body behaves purely as motion under gravity, which we have considered before. So the body will experience all the equations for the upward motion we discuss, and all the equations for the downward motion we discuss. So take note of that point. So for the vertical motion, the projectile or the body moves up and down with acceleration due to what? Gravity. So the vertical component is affected by gravity, but the horizontal component is not affected by what? By gravity. 2, it means that the initial vertical component of the velocity at the highest height, the maximum height, is what? Is 0. So this means that the projectile has no vertical velocity at the what? Maximum height. So you remember we were using that in our derivation, where I would say at the maximum height, the initial velocity is what? Is 0. Actually, it is the initial vertical component of the velocity that is 0 for the downward motion. Then it also means that the vertical or y component of the velocity will increase by this value as the body accelerates downward. What does that mean? So as the object is falling down for the downward motion, for the vertical motion, the body is increasing with a constant rate, which is the what? The rate of acceleration due to gravity. And this is the value, or approximately what? 10 meters per second square. And lastly, it means that the initial vertical component of the velocity changes with time because it is subject to what? To gravity. So the long and short of this point is the vertical motion of a projectile is affected by gravity and obeys all the equations of motion under gravity for the upward and downward motion. 2, the horizontal motion is not affected by gravity. Hence, the body's velocity or speed is constant and uniform from the start of the motion to the what? End of the motion. Take note of those points. I will apply it, especially this horizontal motion. I will apply it in the next class. Please remember to subscribe if you have not done so. Share this video. Let others learn from this class. Bye-bye.